Hello science students. We're here at a geothermal vent in northern Iceland. This smoke you see coming out of here is actually not smoke but steam. Below us there's liquid hot magma that is superheating water that's coming up in various different forms. Right here it's coming up as steam. Just over there it's coming up as boiling hot springs, and there's also bubbling mud everywhere. And what makes this park so unique to scientists is that we are actually standing in the mid-Atlantic rift. And if you remember how we studied geology and the theory of tectonic plates, giant plates are floating on top of liquid hot magma. Right here, however, we have two plates that are starting to pull apart. On my right-hand side, we have the North American plate. On my left-hand side, we have the European plate. And they are slowly tearing apart, and that is what creates such dramatic volcanoes and hot springs and geysers and hot pots here in Iceland. It is a very geologically unstable place. Now, all of this geothermal instability creates large and impressive hot springs all over Iceland. Here we are enjoying one of the most famous, the Blue Lagoon in Reykjavik, the capital. In Iceland, we're at what's called the Blue Lagoon, and it's famous for being these amazing hot springs where people are allowed to swim in, but that's not the main purpose. It's actually the hot water is a byproduct from a power plant you see behind me. And the unique thing is, the scientists have figured out by studying geology that there are pockets of hot water trapped below the earth. They're being heated by liquid hot magma, and what they've done, the engineers have figured out how to bring that water up to the surface in order to make electricity. So 99% of Iceland's electricity comes from these geothermal power plants. And on top of that, it makes a pretty cool place to come and enjoy the amazing hot healing waters of a hot spring. The first step in making electricity in a geothermal power plant is to drill a hole down to where the superheated water is. Step 2 is to bring that hot water up and let it release as steam. The steam then turns a turbine, and you can see in step 3 that that turbine will spin a magnet in a generator, making an electrical current. That electricity can then be put on the grid and brought to people's houses and businesses and schools. The water can then head to a cooling tower where it can cool down and then be either pumped back into the earth via the injection well in step 5, or, in the case of the Blue Lagoon, pumped out into a giant swimming pool for all to enjoy.